Say Intan Uchila or something like that.
Oh, that means that a nonsense name has to be identified anyway.
Yeah.
But once I block a genuine student, then he will not be able to, and he or she will not be able to enter again.
Yes, sir. Sir, he has joined, sir.
How can I remove? I don't know. Then I have to come back again. Don't
Sir,
remove
you
me.
can just again he left. Sir, you have to click on the third. If you go for the list of the student who have joined, there you will see three dots are there.
Hmm.
And
You
Nila, you can
can.
show the by sharing the screen just once
Oh,
if
acha,
you are
acha.
on a laptop.
Just wait.
প্রবল একবার
And
স্যারকে বলে দেবে কিভাবে করে আমি নিজেও পারি না ভালো করে দেখবে
না
দেখিয়ে দাও
আমি বুঝতে পেরেছি, দাঁড়াও একটু দেখে নি। Unfortunately, he is appealing again not to remove. I don't know what is his purpose. But he can speak out then. That's the problem. If he has genuine reasons of studying, okay, no issue. But why he is joining, that's also... Anyway, today's class will go for that nuisance.
so if you hover the mouse pointer on on any logo, then you can see three options.
But he is telling,
Yeah.
I want to study, not to disturb. They are sending message continuously.
No, sir,
Yeah.
just ignore him. And if you hover the mouse pointer on any logo, you can see three options. One for mic option and mute option. One for mute, one for remove. And can you see, sir?
Just 1 minute.
If you just keep the cursor on any logo of our student.
Remove Probal set. I don't know. I don't understand. Anyway.
Okay, just ignore, sir.
No,
Something happened then.
he is giving some message also that he wants to do the attend the class. If subject wise, if somebody wants to attend the class, I don't have any problem. But he should speak out. Why he's playing some hide and seek? So he can declare opening his microphone and then telling me that, okay, this is my objective. He's just listening to all our discussions. So,
Sir, you can start the class.
no, don't try to give me advice of everybody. Okay, don't become my advisor. We have started the issue. I will decide when I will start the class. So the problems are many. Everybody is just looking from their own directions and they are trying to advise me. Your friends are still entering. Can you manage those students who are coming late? So don't try to advise me whether I should start the class right now or not. There are so many students who are joining so late. But they should be also...
So I have given the link half an hour ago. Still now they are joining late. So after 8:10 you may start the class and do not let anyone enter after that.
Okay, so it is yet to be another 2 to 3 minutes. Then I will not allow.
Yes, sir.
So many nuisances to be managed, and then just don't go on telling like what you suggest. This is irritating to some extent. I will follow the class here. By the way, what about the class rescheduling? That's another important issue for me. If we can do that in the normal schedule, then it's fine. Then what can you do? One option is basically, so most probably Monday 2:30 to 4:30 is finally decided, no?
Yes, sir. Yes, sir. We have already decided Monday afternoon we are free.
Monday afternoon, you people are free, and so many things. The digital tab is also creating problem. Then Shantanu Bormon, is he your student? I don't know who is
Yes,
your...
yes, sir. Yes, sir.
Anyway. And then somebody is telling that he wants to attend the class, but he is not belonging to the class. So many things are coming up anyway.
Sir, the decided dates are Monday from 2:30.
And then another class is in which date?
Sir, Friday from 10. You told you are having an engineering drawing class, I think. But you told you will adjust that and settle the group. Means we have 1 hour class, so you told that you will take the 1 hour class and You will adjust the timing with the first year students.
Either classes cannot be changed, no?
So no, sir, it will be very tough because our departmental subject classes are there and we have to arrange there. No dates are there in the afternoon slot.
So afternoon slots, no dates are there. Okay, fine.
No, sir. Means as it is reopening now, so in offline mode, I don't think we have any more classes, means slots left. I have checked through the routine. If it was online, we could have done it in the evening or something, but in offline mode, it's very difficult.
Okay, so maybe I can sometime decide to what to do. Sahel Rana Mandal, is he also belonging to your class?
Yes, sir. Yes, sir.
Okay, so in this class there are some difficulties with the student. I mean, this I never faced earlier. I mean, so many confusions and anything. Anyway, so let's go to the class content today. So unfortunately, I'm not sure whether I'll be able to make the boardwalk today because this has also some problems with respect to my. Let me check. Oh, before that, I have to start the recording. Whiteboard, full screen. Oh, yeah, recording option is now withdrawn because Jadavpur is not subscribing anymore the G Suite. That's why.
Can I show that the remove option for just quite second, for some second, and by sharing the screen?
No, I cannot find him currently at here, so I cannot just run after him repeatedly. Once he has got it, let him attend the class. Then if he does the nuisance, then maybe we have our one or more maximum online classes, so we don't bother. So I cannot record it right now. Okay, fine. So there is no provision of recording, so obviously I have to proceed without recording. Just let me check it. No, it has to be set in that way. The connection is not, yeah, let it be. Okay, you can see my boardwalk now. Can you see that I'm drawing some lines, etc.?
Yes, sir.
Yes, sir. Yes, sir.
So our subject name is thermodynamics. Let's see how it is possible to draw. So how the word thermodynamics came? Any idea? Because you have studied thermodynamics in high secondary also. No idea. No, that's the subject content you are trying to explain. But how the name itself came from? Is it an originally English word?
Sir, thermo means temperature, I guess. So from there we
The
got
flow of heat from one substance to another, means one matter to another.
Anyway, I have understood that. That's then. I mean, it's not necessarily that it has to be explained in the class previously. Anyway, so I'm giving that this is consisting of two Greek words, THERME, therm, and that means heat. And another word is dynamis. Dynamis means force. So interestingly, the subject thermodynamics originally started with, though it's now an English word, but it started with two Greek words. One is the thumb means heat, and another is the dynamis. So obviously, this subject, as it takes care of, you all know from your higher secondary knowledge, that it takes care of associated heat and as force, associated force multiplied by the distance give you the work. So the name in originally taken care of by the heat associated any force that comes up. So just write down the subject thermodynamics, the subject name thermodynamics originates from two Greek words. Therm means heat and dynamis means force. This subject deals with heat, associated force, and any work coming out of that interaction. Okay, so we know the subject name started from the, it's not the original English, it's originally two Greek words. Now the issue is, who studies the thermodynamics? Some of the students are trying to enter, I will not allow. Okay, so now the question is, who studies the subject of thermodynamics? The subject of thermodynamics is studied by, as I explained in the first class, both by the people from the science background and the people from the engineering background. But their approach towards them is different. So just write down a little bit. The subject of thermodynamics is studied by almost all branches of science and engineering. However, next sentence, however, the approach towards the subject is different in science and engineering. Science people are mostly interested to gain fundamental understanding of the physical and chemical behavior of a fixed quantity of matter. And uses principles of thermodynamics to relate the properties of matter. But the engineers, next sentence, but the engineers are mostly interested, though there is some overlap with science people also, are mostly interested with interactions of real life engineering systems with its surroundings, and gaining utility output from it. Okay, go to the next paragraph. So at least whatever has been explained, the subject is common, name is also same, and obviously no truth can be different if the people study the same subject by different group of people. Truth are same. So there must be some connections also. How these two are connected, that the science people follow the principle of thermodynamics and the engineering people follow the principle of thermodynamics. And that's why currently all books are named engineering thermodynamics. The people follow. So the science people don't write scientific thermodynamics, they simply write thermodynamics. So there is a difference in approach. We have already mentioned that science people are mostly interested with the given certain quantity of matter, they are interested with the property explanations of those matter. But engineer people are mostly interested, if required, property study will be there as a part, and that's why in some cases they become very much overlapped, engineering and science. But mostly they're interested with the interaction between the system and the surroundings, and from that principle they are interested with how much utility output we can obtain out of that, from that. Now the approach towards these two the group of people becomes different as their study method also different. Do you have an idea what is called macroscopic thermodynamics and what is microscopic thermodynamics? From the name itself, there should be some common sense idea that macroscopic thermodynamics will look as a whole in a macro approach, and microscopic thermodynamics as a whole will look into the subject in a micro approach. So what do you mean by macro approach and micro approach? So let's go to the next paragraph. This, as science people are mostly interested with explaining properties of matter, they always look into a system at molecular level. Full stop. We know any matter consists of large number of molecules full stop. So the overall behavior of a system must be explainable from the activities at the molecular level. This approach of thermodynamics is called microscopic or statistical thermodynamics. Microscopic or statistical thermodynamics. it is obvious that this approach is very much fundamental but involves significant effort to explain behavior of even a small amount of a matter. Go to the next paragraph. However, engineers are mostly interested with larger systems which handle larger quantity of mass. Full stop. To explain phenomena for such a large quantity of mass, from molecular level of activities is very difficult. Hence, engineers look into a system in a bulk approach, BULK, in a bulk approach rather than exploring systems at the molecular level. This approach is simpler. This approach is simpler for analysis and better suits for large-scale engineering systems. This approach of thermodynamics is called macroscopic or classical thermodynamics. And even engineering thermodynamics in a simpler terminology. Okay, so at least I hope that I could explain that what is the difference in approach towards the same subject thermodynamics by the people from science background and people from the engineering background. Because science people, their interest is obviously explaining the properties or behavior of a matter. They're not concerned much with the utility part. So to explain that thing, they have always preferred the most fundamental approach, because effectively any matter or mass may consist of large number of molecules. So any explanations of the overall mass system must be explainable, because that is truth. Eventually, these are all coming from the molecular level activities. But the engineers, as their systems are quite larger, say, in a large boiler, that's maybe a 4-story, 5-story building size, and the entire coal given is some tons in some hour. Okay, even less than hour, it may be several tons. So obviously that large number of mass, if you want to explain all their behavior from the fundamental behavior at the molecular level, it's almost impossible. So what the engineers have taken the approach is, they will not go into the molecular level, they will take as a bulk approach. And that bulk approach is called macroscopic approach, and that has come out, alternative name is classical thermodynamics, which is even today's day-to-day life, we call it engineering thermodynamics, which is a simpler terminology. Now the question is, but we have understood that the approach out of these two, undoubtedly the science people thermodynamics approach is more fundamental, because they are going to the root of cause of behavior of a matter. We are not that. Why? Because we are not interested to explore those things. This is the fundamental science people's cup of tea. But our cup of tea is basically getting some practical utility output from the interactions between the system and the surroundings. But as their approach is more fundamental and our approach is to some extent simplified for the purpose of utility of engineering applications, do you think that there are certain limitations of our engineering approach?
Yes, sir. There should be.
What sort of limitation? No response. Okay. Now,
Don't know, sir. They are taking that in molecular level, so that would be their approach is more appropriate.
that I've already mentioned in the text. But then what are the limitations, or rather, better to say, if you can always go through the bulk approach, the analysis becomes simpler, that means engineering approach. But the fundamental science people don't go, not because it's their whim. Their explanations of properties of matter is only possible fundamentally going from the molecular level. So, it's not that they are also doing it just out of their own ego or compulsion, They are doing it out of their compulsion only. So the question is, but the engineers have made their simplifications because the mass is substantially higher in engineering systems. Any of the engineering systems involve mass is substantially higher than the, say, a chemistry reaction. That generally happens in a very small beaker sort of thing. So that explanation we can give it, very easily. But the engineering systems, as I am given the boiler, compressor, if you just name those large engineering systems, several tons of fuel input may be there within an hour. So obviously what to do? Now the point is that engineers has to follow the bulk approach, no option. But now my question is whether engineers are also restricted in some cases to follow the more fundamental approach, which is the statistical thermodynamics approach. And what is the compulsion when you are bound to switch over to statistical approach, because that is a more fundamental approach. But engineering or classical thermodynamics approach is a simplified approach which may not be always valid. Any response? No. Okay, just come to the point now. In engineering thermodynamics, what we are assuming? We are assuming there is no molecule, but there is some amount of matter or mass. That means you are tacitly, whenever you are going at the molecular activity level, you are assuming that there is an intermolecular space or gap. Molecules can never be continuous because individual molecules are independent identity. So obviously, when you are looking at the matter as a overall approach, which is the engineering approach, then we are ignoring the molecular activities, means we are not considering any intramolecular spaces. We are considering that it is a continuous substance. Try to understand, the text will be given later. And this assumption of continuous substance is possible rather most of the cases in engineering systems, but in some of the engineering systems you will find out this continuum, I mean the assumption that the substance is continuous may not be always possible. And from that we have scientifically defined a term which is called continuum. If the continuum condition is valid, then only you can assume for practical applications the substance to be continuous. But if the continuum condition is not valid, obviously your assumption of a continuous substance, which is assumed for the engineering analysis, is not valid, and you are bound to switch over to the statistical thermodynamics or microscopic thermodynamics approach. Now the point is, if that is the case, how the continuum condition is defined? Just before that, write down that particular up to this, whatever I want to convey. The classical thermodynamics approach assumes any substance to be continuous within quote.
So assumes then
Substance to be, any substance assumes to be continuous within quote, without having any so-called intermolecular, sorry, not intramolecular, intermolecular spaces. Without having any so-called intermolecular spaces. This condition regarding any substance is called continuum condition, CONTINUUM. Full stop. Then you write down, if the continuum condition is valid, then either of the classical or statistical thermodynamics may be used for analysis with acceptable accuracy. Okay, so conceptually what you have put, the proposition, classical thermodynamics assumes no molecular level activity. So it considers that any given substance or matter is a continuous one. But statistical thermodynamics, as it considers, rather explains the overall behavior of a substance from the molecular level activity, they cannot ignore the intermolecular spaces rather. So obviously, according to statistical thermodynamics, this is their systems are always non-continuous, always. But continuum condition has to be satisfied to apply the classical thermodynamics. So in some cases, when the continuum condition is not valid, engineers are also forced to follow up with statistical thermodynamics approach. In fact, we teach statistical thermodynamics. I also teach this subject of advanced thermodynamics in mechanical engineering PG courses. So, but that is not there in the undergraduate courses. Now, the point is, if that is the fact, then we have to understand how the continuum condition is determined. Any response?
Sir, what question, sir?
What? Work?
Sir, repeat the question, please.
Oh, we understood that the continuum condition has to be valid to apply the classical thermodynamics. Because if the continuum condition is not valid, then we are bound to use the statistical thermodynamics or microscopic thermodynamics approach. So how do you justify or rather test whether the continuum condition is valid or not?
Sir, if both the engineering and scientific approaches yield the same result.
So why red is red? Because it is not blue. That's the answer. Anyway, so just try to just think about the situation. Now, actually, there are molecules, intermolecular spaces are also there, but you want to ignore. So if the intermolecular spaces are small with respect to some concept or measurement, then obviously we can assume or ignore that intermolecular space and neglect those intermolecular spaces and assume the substance to be continuous. This is common sense issue. Now, when it will happen? When the density of the molecules in a given volume or space of the matter or mass is quite high. This is not the physical density, molecular density. And all of you know that any molecule has a movement, either in the solid, liquid. In the solid, it is vibration mode. It is gas. It is a velocity mode. Now, the issue is if the intermolecular spaces is significantly large, then obviously the continuum condition may not be possible to accept at the way of analysis. And then what we have to, how to determine that continuum condition? We know that there is some definition of mean free path. And if the mean free path is significantly high with respect to the dimensions of the entire system, then obviously continuum condition may not be possible to accept to be valid. And then just go to the text, next paragraph. As the mean free path is defined to be the distance covered by each molecule before meeting another molecule this with a comma, this decreases with number of molecules being larger for a given space or volume. Full stop. If the mean free path is of the dimension of overall extent, extent, overall extent of the system, then the continuum condition may not be valid. And statistical thermodynamics approach is a must. Okay, so we are moving step by step. Initially, we have explained that science people, how they follow the thermodynamics, engineering people, how they follow the subject of thermodynamics. Now we have explained between these two approaches, where lies the connecting link. Link is basically the continuum condition, because undoubtedly statistical thermodynamics is much more difficult to apply than the engineering systems, and the engineering systems is rather impossible real life systems to carry with statistical thermodynamics approach, because there are a large number of molecules within most of the engineering systems, and for each molecule monitoring with their corresponding parameters like velocity, locations, etc., you have to carry out with each of the parameters involved with each of the molecules. In fact, we do it in statistical thermodynamics in our teaching also in PG level. But there is a compulsion that if the continuum condition is not valid, and how the continuum condition will be determined, we have mentioned one term, extent. Extent means mean free path is a linear dimension, but the volume is a rather cubic of the linear dimension. So we cannot compare the mean free path with respect to the overall volume, but the volume can be considered as if the extent means where the entire system is occupying the space. So if with respect to the entire system occupying the space, not considering the volume part, though it is physically volume, that is called the extent of the system, is comparable with respect to the mean free path of the system. Means, say maybe some millimeter level becomes the mean free path. Then obviously your density of number of molecules, not the actual physical density, the density of number of molecules become pretty low with respect to the given extent of the system. If the system is such, then obviously you are bound to go through the statistical thermodynamics approach. Let's go through an example now. You are all habituated with, if a given cylinder, or if a given a football, rather the inside there is a bladder, that has to be inflated with air, etc., etc. That means any system with certain amount of gas filled up at normal atmospheric pressure, maybe the system is quite large. That means the volume, entire volume is pretty high, but the pressure is either atmospheric or above atmospheric. So my question is, if you measure the pressure value at different locations of that system, will you get the gas pressure to be identical or different? Is the question clear?
ডিফারেন্ট লোকেশন মানে আপনি কি প্রেসার ভ্যারিয়েন্সের কথা বলছেন?
No, I'm talking about it's a comparatively real life large system, maybe of the order of some meter cube volume, and it is filled up with a gas, say air, simplest possible gas, at atmospheric pressure. Now if you want to measure the inside atmospheric pressure, inside pressure of the gas at different locations of that system, maybe at top, bottom, side, right, left, will you get the pressure different or same? Some network problem. Anybody else?
Sir, same, I guess.
Same.
Same pressure, sir.
সেম প্রেসার।
But that's a common sense. Now, just after measuring that same pressure at different locations, assume the pressure measuring instruments can measure atmospheric pressure also, and very low pressure than atmospheric pressure. This is a theoretical assumption, generally not, because the pressures that measure at the atmospheric pressure level, they are not acceptable. They don't have acceptable accuracy at very low pressure. Very low pressure measuring devices are a little bit different. Actually, that's there the concept of gauge pressure, vacuum pressure gauge, etc. comes into the picture. Anyway, we'll come to that later on, the device part. But if you assume that the devices are such that they can measure atmospheric pressure and simultaneously very low pressure. Then what we are trying to do, initially it was at atmospheric pressure. All the pressure measuring different devices at different locations are showing identical pressure. Now, with a vacuum pump, we are extracting air from inside the system. So what is happening? Physically, the pressure will decrease. And look into the statistical approach or molecular activity level approach. For the given extent means what? Where the masses of that system exist. Obviously, that's the volume, but I'm not telling volume just because of clash between the dimensional matching of linear dimension and the volume of L cube dimension. So I'm using the term extent. Now, on the basis of this extent, obviously the number of molecules are decreasing. And if the number of molecules decrease, physical manifestation is by observation of pressure decreasing. But at molecular level, what is happening? Number of molecules in the same extent is continuously decreasing with the extraction of the gas from the system. Now, at very low pressure, what do you expect? Still the pressures at different locations, if you can measure with suitable sensitive instruments, do you expect that pressure measurement will be same? I don't know whether this has been this sort of discussion, because this experiment is impossible to do at school level. There are some sophisticated laboratory who can just show this experiment with proper suitable pressure measuring devices. But anyway, it may not be possible at school level. I fully agree. But do you have any explanation in the school, or rather, do you have any idea that initially pressure at every locations will get same? That's a common sense observation, and we have seen it also. Rather, those experiments maybe you have done. But if you want to go on extracting the mass, eventually decreasing the pressure to, more and more, decreasing the pressure more and more, then obviously at very low pressure, close to the vacuum pressure, that means absolute vacuum, no pressure, zero pressure, will the pressure, if the pressure measures at different locations of the system, do you expect that you will get identical pressure or different pressure? Just imagine your, rather extend your imagination rather.
Sir, near the bottom of the chamber, the pressure will be higher than at the top of the chamber.
Good.
I think.
This is one guess. Anybody else? Any other guess? Because initially science starts with a guess, then it's get confirmed with respect to the experimentation, and obviously theoretical modeling is very much important, because modeling both in science and engineering both are important, but engineers has got their different approach in modeling, but science people have got also different approach in modeling. Okay.
Sir, sir, we are making the entire chamber vacuum, so I guess the pressure would remain the same everywhere.
So you are expecting that even at low pressure, it will behave similar to the atmospheric pressure zone, is it?
Yes, sir, almost similar to that.
Almost similar. So that's your claim. Anybody else? Any other opinion? Because it should be a little bit interactive and imaginative, so that can help you learning better. Nothing. Okay. Now go to the, here the clue is the pressure measurement by an instrument, but the feeling of pressure all of us have. It's a feeling basically. If you just consider the higher pressure, low pressure, like temperature also, it's a feeling. And interestingly, thermodynamics, before the term entropy is introduced, almost, why almost? Yeah, in between there is some internal energy properties also a little bit confusing, not from the physical feeling, but almost, should I say, almost all the parameters are perceivable from our sense organs. Okay. So think about the pressure condition. We can always feel by putting a finger on any part of our body and then increasing the pressure. How do you feel the pressure? Feeling higher pressure, low pressure, obviously skin will say, and the nerve just below the skin will let you know that you are subjected to higher pressure or lower pressure. And obviously, if you are in a rather deep sea, rather than the under the depth of the sea, you will physically have on your overall body. That means the pressure is a physically perceivable feeling, which is actually measured by the devices also when the pressure is closer to normal atmospheric or little bit below or little bit higher than that. But what is happening at the molecular level, how the pressure is being generated, it's just because molecules are colliding with container wall inside, and then they are having their rate of change of momentum of individual molecules due to that collision. And that actually, according to the Newton's law, the rate of change of momentum is the force, and then how many number of molecules are colliding at a particular point will be total rate of change of momentum. And is it not the force per unit area if we just consider? So the pressure measurement or pressure feeling by our perception is actually originating from the microscopic approach as the rate of change of momentum of number of molecules per unit area colliding at a particular point. Why this comes out to be same if you measure at different locations? Try to physically understand the situation. If the number of molecules within a given extent is substantially higher, then what will happen? Statistical average. That's why it is called statistical thermodynamics. Statistical average of number of molecules colliding per unit area will be, or rather better to say even more accurately, overall rate of change of momentum due to the collisions of those molecules in surrounding wall containing the gas will be almost or to the acceptable accuracy identical. But if the number of molecules decreases, then what we will expect? There is a possibility or probability. That means statistical averages give the same value. You know, all of you, that the classical example we have started, tossing a coin. Mathematically, we say the probability of coming out with head or tail will be 50-50. But this will be absolutely true if you go for very large number of tossing. So any statistical average is good for estimation and quite accurate also for large number, theoretically tending towards infinity. But for a smaller number of tossing, you know, if you do 2, 3, 4, 5, 10 tossing, obviously it is expected more possibilities it will be biased on either head or towards tail. Maybe 6 times, even 10 times can be subsequently head. So statistical average or probability values are not valid if the number of sample studies are less. Here also, when the number of molecules are decreasing with lower and lower pressure, in physical experimental measurement of the pressure at a very low value, if you measure at different locations, it has been proved it will appear different. So what is the difficulty? Difficulty is if we have to take the entire mass of gas to be our system in classical approach, then the pressure also has to be uniform in classical approach. But actually pressure is not uniform. At different locations, pressure values are also different. Obviously, our classical approach is invalid because continuum condition is also not satisfied in that condition. We are bound to go to the statistical approach. Do you need the text for this, or you have understood?
Sir, you can give the text. Dictate me, right?
It will be better. Anyway, so
Yes.
just in short, what can I say? If some amount of a gas is contained in a container at a pressure closer to the atmospheric pressure or higher, then measurement of pressure of the gas at any location of the container will be identical. Full stop. Next sentence, if subsequently gas is extracted from the container, comma, pressure will continuously decrease and eventually may reach to a very low pressure close to vacuum pressure, close to absolute vacuum pressure, VACUUM, close to absolute vacuum pressure. Full stop. Measurement of pressure with suitable instrument at different locations at that low pressure will show different value of measured pressure as experiments confirm.
Sir, as experiments?
As experiments confirm. That means this you have observed
Okay.
through experiments. Okay. Full stop. This is because pressure inside the walls of the container is generated due to rate of change of momentum of molecules colliding on the surface. Full stop. If the number of molecules in a given extent is significantly large, then this statistical average of rate of change of momentum at any location of the container will be identical. And hence, measurement of pressure at different locations will also be identical. Full stop. But for a high vacuum system, VACUUM, this probability of average rate of change of momentum at different locations of the container is not valid and hence measured pressures will also be different. Full stop. It is noted from this example that statistical thermodynamics is valid for both of these examples, though not classical thermodynamics. as the continuum condition is not valid for high vacuum systems. Areas where classical thermodynamics, areas engineering engineering application areas where classical thermodynamics is valid and useful, maybe steam and gas power plants, IC engines, compressors, conventional refrigeration and air conditioning, etc. But areas like high vacuum systems, plasma, PLASMA, laser applications, cryogenic applications, classical thermodynamics fails. And statistical thermodynamics is mandatory even for these engineering systems. Okay, so I just wanted to convey the message through today's class is because we will be going through the classical thermodynamics approach. But interestingly, here you have to remember that though tacitly we will always assume that this continuum condition is valid, and this happens maximum cases of engineering applications, but it may not be true in all the cases, and we must be aware that some of the real life engineering systems will also not be valid for continuum condition. And based on this, we have to apply, engineers are also bound to apply the statistical thermodynamics approach in those applications. Examples are given. Cryogenic systems, very low temperature applications, where obviously at low temperature, from your physics experience, you know that the molecular movement also decreases as it approaches to your so-called 0 Kelvin at temperature. Then it becomes so low that they become immobile, and that's why the volume becomes effectively zero of a gas. Anyway, so from that concept, actually, there the continuum approach is getting violated as we go to the very low pressure or high vacuum systems. Similarly, cryogenic systems, similarly, plasma, laser also examples. And obviously, in those explanations or rather in those systems analysis, we are bound to, even the engineers are also bound to follow the statistical thermodynamics approach. Today we have around 15 minutes, so I think the next topic, today what I have done then, the class topic today we have covered is basically the macroscopic and microscopic approach of thermodynamics, if I make a summary at the end, and where they are applicable. And we have also understood from this discussion that any macroscopic manifestation, just write down at the end, this is very important sentence actually, just write down, any macroscopic observation can be explained using microscopic approach. But this may not be true for the reverse truth, reverse fact. What should I say? For the reverse possibility. For the reverse possibility. Anyway, I just want to mention that you can explain the macroscopic, any manifestation can be explained by the microscopic approach, but all the microscopic approach may not be always explained even by the macroscopic approach, because we are assuming the continuum condition. So hence microscopic is more fundamental approach, though I have mentioned most probably previously also. Now, as there is around 15 minutes time, I can answer any queries, and then I have to go to some practical issues and the roll call, etc. Any queries up to this? No. Okay, so I can assume that there is no queries, so I can come out of the system. So how to yeah. And hopefully next week we are going to have our classes to be started rather offline. And
So is it confirmed?
at least the government has announced already. On
Yes,
3rd
sir.
February the classes, university will open.
Okay, sir. Okay, sir.
If the university opens, then obviously we have to take the
Yes, sir. Means actually the university has not yet given any notice to us. So I hope they will provide us immediate.
No.
As
Then
soon as possible.
how the administration system proceeds, if anything comes from the government order of state government or central government, then each of the sections, because government make it a general principle whether we will follow the rather the schools or academic institution will be open or not. And government is not announcing only for academic institution; it is simultaneously announcing for other business and entities also. So then what happens? Then the individual departments issue their government order or notice. Like education department issue their notice that this will be valid for, educational institution, and that notice has also come up in our teachers association group. We have received those forwarded by the Provice Chancellor and other colleagues. So obviously we are going to have our institution open by 3rd of February. Now my point is, though it will take some time, I'm absolutely sure, because there will be some fluctuations, but we have to go for the theoretical. We have to go for the rather fluctuations for some days anyway. So what we will try to do, we have our next Monday class. What are the dates? Friday and Monday. Monday we have shifted to 2:30. Friday this week, I may be a little bit confusion whether I can manage it, because I have certain constraint on Friday also. So I will let you know by Thursday. And then one day class is not an important. If required, I may have to shift the class because so many things have become, clubbed. Clubbed means rather complicated. I have some 2 carryover classes from the first year students from the previous semester. That means the semester that you have ended up. And I have 3rd year classes which have started much earlier, 2nd year classes recently, and the 1st year classes of the last semester is also continuing. And I have told you here that some of the classes has overlapped in the routine because university is instructing me to continue the classes simultaneously in different classes. It's not possible. But university is also helpless. We cannot blame each other because the situation is so demanding that we cannot just accommodate the classes separately also, because so many classes, so many overlaps, and the semesters are also getting some overlap situations, and it's a complete mess situation. So if required, I may have to shift the class on Saturday also. I'll be bound in that case, I have to see whether, because Saturday is basically providing some buffer day, though I don't like to go to university on Saturday, but then let's see. So this Friday, I have to check whether I can take the physical classes. Otherwise, I'll inform. Sir, please call me by Thursday evening or Thursday night so that I can decide by that time whether I will be able to take that class. And then obviously in Monday 2:30 class will positively be there. 2:30 to 4:30, 2 hours class is very important. So we will try to cover up those, or rather start physical classes at least from Monday. That is confirmed. Anyway, so now let me have the roll call. What is today's date? 31st. Okay, so B3 roll sheet I missed in the last class. That I can manage now. Anyway, this is the B3. I hate doing roll call, but I have to. No option. Anyway, so roll number 1139.
Present, sir.
Then 140. Ankit Prasad. No. Then 141.
Present, sir.
Okay.
Praval.
Then 142.
Yes, sir.
Someone is trying to join the class still. Sam Malik. You see how interesting. Anyway, so 143 is also present.
Present, sir.
142 Pranay is present. Then 143 is also present.
Sir, 140 also present, sir. Ankit Prasad.
Oh, okay. And then 145. 145. No. Then 146. Then 148. 148.
Present, sir.
Then 149.
Present, sir.
150. No. 151. Aishik Bishash. No. Then 152. No. 153.
Present, sir.
Ritam. Then 154. No. Then 155. Krishna Bor. No. Then 157. No. 159.
Yes, sir. 159.
Defalda. ठीक है. And then 1160. Shuman. No. Then 161. So weak. ठीक है. Then 1162.
Present, sir.
Okay, thank you. Then we have B2 section. 163. 1163.
Present, sir.
Then 164.
Present, sir.
Then 165.
Present, sir.
Then 166.
Present, sir.
168.
Yes, sir.
169. Or no, absent. Then 171. 171. Anyway, absent. 172.
Present, sir. 172.
173.
Present, sir.
174.
Present, sir.
174 present, huh? ঠিক আছে।
Present, sir.
176
176 present, sir.
177
Present, sir.
178 Sanskar, no. Then 1179
Present, sir.
180
Yes, sir. Present, sir.
181
Present, sir.
182
Present, sir. 182.
183 Priti Dash, no. 184 185
185. Present, sir.
okay. 1195
Present, sir.
Then B3 section 1196
Present, sir.
present in previous class also. Okay, then 1197
Present, sir.
presence in previous
Sorry,
class.
sir. 1198, sir.
1197 not present, okay, absent, maybe both classes. Then 1198 Onkon is present in both classes.
Yes, sir.
Okay, then 1199 okay, you are there, huh? 1199 no, some noise are coming, no.
Network issue, sir. I think he has network issue.
So he was present in both classes, no?
Yes.
Okay, fine. Then 1 and then 200 Rohit,
Yes, sir.
okay, you are present in both classes.
Yes, sir.
Okay, then 202
Present,
Sahil
sir.
Manapandal, you are present in both
Present, sir.
classes.
Yes, sir.
Okay, then 203 Orijit Shaha, present in both classes. No. Then 204 present in both classes. No, he is absent. Then 205 206
Present, sir.
okay, present in both classes.
Yes.
Then 208 maybe absent. 209 Arindam Maji,
Present, sir. Present, sir.
both classes, okay.
Yes, sir.
Then 20210 Orit Murmu, absent, okay. Then Monish Kumar 211
Yes, sir.
present in both classes.
Yes, sir.
212 Ovik Pal, no, absent. Then 213 Shubhadeep Dotto. Then
Actually, sir,
21
Subhadip Datta has left the university.
oh, okay, fine. So I put both this anyway, so I can just cross it. Let's see. And then 214
Yes,
okay, present in
214 present.
okay. Then
Yes, sir.
215
Yes, sir.
present in both classes.
Yes, sir.
Then 216 Gautam Gorg, present in both classes. No, he is absent this today. Then 217
Yes, sir.
Onusha, present in
Yes,
both
sir.
classes. Okay,
Yes, sir.
fine. Then 218 absent. 219 Vishnu Gupta. Then 221 Siddhant Singh.
Left the university.
Oh, he has also left. And CR, you have given me the lateral entry students list, no? In WhatsApp.
Yes, sir. Yes, sir. I have sent you to you
You have sent
separately.
you, but the teachers have so many things to do. Actually, master role section they should provide in our online system. Nobody does anything.
Sir,
Everything-
its authority is not providing with any of the teacher. We have to only provide it.
I'm not blaming you. Why? I'm also.
Yes, sir.
blaming-
I know, sir. I understand because most of the teachers are asking from us only. So
It's
we are
very
only
nonsense
providing.
things because teachers has to teach, teachers has to take all this official responsibility, teacher has to take all the marks and everything, control of examination sections, everything teacher has to do. It's really painful, and that's why students are also suffering, teachers are also just getting lost into the entire system. Anyway, so I can just assure that the those names I will copy today, but this should have been the ERP system is there. They should just upload those bona fide students to the list so that we can get the printout directly. Now I have to take those things again from the system.
Sir, I am interrupting you, sir.
Mm.
Sir, I have sent you a Excel sheet.
Mm.
So in the Excel sheet, we have all the total students list. Means those who have left, I have left them
No,
out.
then see, my job is to just find out the which names are not there. Then I have to put it there and then copy it.
No, sir. You can just go through my list only. It's a complete Excel sheet with the updated one. Means if you go through it.
Will your Excel sheet work when the physical classes will be there?
Yes, sir. Yes, sir. We have, according to the roll number, it is order set in the order.
The point
And it
is,
contains the name of the lateral student as well as I have cut out the name of the students who have left the university. So it's an updated list.
So I have to do these things in the hard copy, because in the hard copy I have to go rather with the hard copy things during the physical classes. Anyway, I have to put those things entry. How many lateral entry students are there? Around 10 or less than that?
No, sir. It's less than that. In our section, we have 4 and here around 5. So 9 students. 11, 10 students only. 10 students.
10 students. So maybe by the next class, and next class, if it is physical, then it's fine. I have to just take those things. I mean, taking account of all the previous classes also. What was the date of last class? I forgot.
So last class on Friday.
Friday means which date?
Friday means today is 31st. So 30.
28.
28, sir.
28 Jan.
Okay, 28 January. So let's hope that, and you see that the university has even ended up with the G-suite. Previously, it was there to record those things, at least for my reference. Whatever I have taught, I have with my recorded. But that also is lost. Everything is getting lost. Only you just maintain the systems as you can. That's the responsibility of the teachers. And that creating the problem between the student-teacher relation also, that is getting diverted to the non-teaching actual things we are doing being the teachers. Anyway, we have to accept. I cannot just tell you these stories actually. But unfortunately, the teachers cannot go beyond certain level of quality of teaching researchers because of the surrounding things are coming more as their responsibility. Unfortunate situation. Anyway, thank you. So hopefully, but Seer, just make a call on the evening of Thursday so that I can tell you whether Friday one period.
Okay, sir. I will ask you. Means on Friday. Sir, after which time you are free?
Around after 7 p.m. it's quite okay. Because sometimes no, you better at least call at least 9, because most probably on Thursday I may take one mechanical engineering.
Okay, sir. Sir, see, actually, third will be following this week only. So if the university opens, I don't think it will be any problem. But if it doesn't open,
no. You see, if you just want to have that class in the evening, and if you make it a decision and put me as a seer, that on that Thursday, Friday class, we will rather prefer to have it online still. You just give me. But I can tell you very frankly, there are some people who are just running after those, mistakes. They go on doing their mistakes deliberately and they try to find the mistakes of other people. So then some people will raise the questions when the physical classes have started, why it has been taken online classes. So that people may always present in the group. Maybe in the students, maybe in the teachers, maybe in the university, there are many people who just go on criticizing others rather than doing what they are supposed to do.
Yes.
So if you, as a seer, can take the responsibility, sir, we can take that class. And I don't think that at least some of the preliminary classes and with the tab, if it works properly, that is almost equivalent.
So, sir, you want to tell that if the university opens also, we can continue the class in online mode for the Friday one?
If you can conclude with the rest of your students that in the
evening.
Okay,
let me talk with the student because maximum students have left. So I will talk in the group and let you know, sir.
Yes. But we can try. But I don't know whether the authority will sometimes force me, because there are many people who thinks that without coming to the university classes cannot happen. Anyway, so I cannot just, I'm not rather denying that some of the sessional laboratory classes must be done physically, but theoretical classes in some cases can be. But decision making, neither me nor you are the decision makers. There are senior experienced people.
Not the decision maker also.
So
okay, sir. If the university allows, means if the authority allows, I let me talk with the student and I will let you know. If the authority allows, you can take it online also.
Yeah,
for the Friday class.
Because I don't want to take those unnecessary nuisance of breaking the rules. But if you feel like comfortable And if you can make that provision, we can continue at least for some days, even with the online classes, so that that will be comfortable for all of us. And I don't think that we will have much difference, because if I can use those tab, I think it will be almost equivalent and comfortable. But I will not
But
take
the Monday class will be online or offline? The Monday, the slot.
Monday class. I can take both the classes offline. But if you want it to be online, then I can go to the online mode also. So, but you have to make it a conclusions from your part without at least blaming me. I can take on your request, but I can also contact my authority.
Sir, Monday class will be very problematic because, sir, see, means we cannot give you the slot of 2:30 if it's online, because, sir, we will be returning home because we have class till, if I don't make a mistake, we have class till 1 o'clock. So after that, we will having a lunch break and we can start continuing the class from 2:30. So if you want to take it online, you have to take the class in the evening hours like today for the Monday class.
No. Monday class also, if I take, any online class after the physical classes have started, I will always take those online classes in the evening also at suitable time, not before 7.
Okay, sir. Okay, sir.
So if you agree with that, that's fine. But if you feel that Monday class should be there, or the offline classes, I will be there on the class also, no issue. So I have both options open. Okay.
Okay, sir.
And let me know that, but the Thursday 10 a.m. class also, if it becomes difficult to change, and I have the simultaneous class for the
Thursday one already shifted to Monday. Friday, I have to check. Friday one, sir, I can.
Friday class. And Friday class that has to be adjusted. And if we cannot, we can just switch over to the Friday afternoon or evening from 7 p.m. also. Okay.
Okay, sir.
Okay, fine. Bye. Thank you. You do this exercise and let me know. If I believe that the teaching learning process is a joint venture between the teachers and the student, if they don't, both of are interested and motivated towards the things will never become successful. Teacher can give his best effort without student intention, nothing will happen. And similarly, if the teacher is incompetent, then also nothing can convey properly in the class. If it is a joint interest and joint competence and rather the intention, then only it can be successful. So you give your effort to make it simplified. I also try. More important is concentrating into the subject rather than the modes and other things that people go on debating and then making a lot of discussions and unnecessarily. Anyway, good night. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hey, Probal. Hey, Probal.
Oi, Probal.
বা এসএনএম না ডাকলে কি সারা দেবে না নাকি?
আরে দাঁড়া স্পিকারে আছে একটুখানি ভলিউমটা কমাই। ওকে।
না কিছু গালাগালি হচ্ছে না, চাপ নেই, তুই নোটসটা পাঠা।